Welcome to my presentation. In this presentation, let us look at some examples related to solving quadratic equations by factoring. Let us say we have an example. In here we want to solve 6x to the power of 2 plus 5x minus 4 is equal to 0. We will use the different steps which we've explained in the procedure in my previous video presentation. We will use that procedure to solve this quadratic equation. Step number 1. We will use the trial and error process first. We'll use let me write that here, trial and error process. And in here we are saying we want to try two numbers and the sum of those two numbers should equal the middle term, and the product of the same two numbers should equal A times C. That is, let me write that here. A times C is 6 times negative 4. 6 times negative 4 is negative 24, isn't it? That is what we have. We want to keep negative 24 intact, but if we were to take the same two numbers, if I were to take 6 and negative 4, 6 minus 4 is 2, and what I need is a positive 5, but what I have here is a positive 2, and therefore 6 and negative 4, this as a first trial is no good. I'm going to put as not good. So we'll keep trying. We'll keep trying for some more numbers, and then that is what this trial and error process is all about. If I were to take another number, like for example 12 times negative 2, okay, 12 times negative 2 is let me write in here. I want to keep the product of A times C as negative 24, and this time I want to look for two numbers which equal negative 24. What if I were to take 12 as the first number and negative 2 as the second number? 12 times negative 2 is negative 24. If I take those same two numbers and if I were to combine them or find the sum of that, 12 minus 2 is equal to 10. 10 is the middle term, what we have is 5, and therefore 10, we have arrived at 10 here, and therefore 12 and negative 2 are not a good choice. So we ruled that out. This is also no good. Let's keep looking. So the third trial, let us say, in here we're going to say we want to keep the product of the first term and the last term as negative 24, but we want to look for two numbers which when we multiply will give us negative 24, but when we combine or find the sum of those two numbers, it should add up to positive 5. So what if we take 8 and negative 3? 8 times negative 3 is negative 24, and if I were to take 8 and then subtract 3 from it, 8 minus 3 is equal to 5. So therefore 8 and 3 are a good choice. Okay, so that's the way we want to be able to use this trial and error procedure to be able to select the two numbers. The two numbers we selected are 8 and negative 3. So we will use these two numbers to expand the middle term. So as step number 2, we're going to write down the given expression 6x squared plus 5x minus 4 is equal to 0, and the middle term we're going to expand that by using these two numbers. The way to do that is as follows: 6x to the power of 2, instead of 5x I can write this as plus 8x minus 3x. 8 minus 3 is 5. Since we have 5x, I'm writing it, I'm expanding it out as 8x minus 3x. These 8 and 3 are coming in from this trial and error process which we have just looked at in step number 1. And then minus 4 is equal to 0. And from this point on, we're going to use the factoring by grouping technique to be able to factor it out. We're going to look at the first two terms and the second, and look at the second set of two terms and see if we have anything common. Between 6x squared and 8x, 2x is common. If I were to pull out 2x common, what is left? If I pull out 2x from 6x squared, I have 3x left. If I pull out 2x from 8x, what is left? 4 is left. Now, in the second set of terms we have, what is common between negative 3x and negative 4? Negative 1. And then what is left? 3x plus 4 is equal to 0. Now, between these two terms, we want to pull out common, and therefore 3x plus 4 times 2x minus 1 is the factored form. Between these two terms, if I pull out 3x plus 4 as common, in the first term 2x is left, in the second term negative 1 is left, so I wrote that in the second set of parentheses, and that is equal to 0. That is equal to 0. In the past, when we factored trinomials, we just left it at this point, 3x plus 4 times 2x minus 1. We just factored the trinomial. But in this example, we want to solve the quadratic equation, and the way to solve that is by using the zero factor property. In step number 4, we're going to come back here and then say either 3x minus 4 is equal to 0 or 2x minus 1 is equal to 0, and that is what is called using the zero factor property. And how do we write that? Here we're going to say either 3x plus 4 equals to 0 or 2x minus 1 equals to 0. And then from here we should be able to find the value of x. The way to do that is we're going to subtract 4 on both sides, and then in here we can write this as 3x plus 4 minus 4. We have adding is equal to, I'm going to write this, let me write it and then I'll show you what I'm doing here. We are adding negative 4 to both sides of this expression, and when we do that, the positive 4 and negative 4 cancels out on the left hand side, leaving us with 3x is equal to negative 4. We want to find the value of x. Therefore, in here we're going to divide by 3 on both sides. Divide by 3 on both sides. And when we do that, why 3, why not 4? Because the coefficient of x is 3, and therefore we want to divide by the coefficient term, which will then make the variable term as equal to 1x. That is the reason why. And therefore these 3's cancel out, leaving us with x is equal to negative 4 over 3. That is our first answer. That is one answer. The second part of the answer is here. 2x minus 1 is equal to 0. So let me put a box around this. This is one answer. The second answer for us is 2x minus 1 is equal to 0. In here we want to find the value of x. So therefore we're going to use the addition subtraction rule. We can write this as 2x minus 1 plus 1. We are adding plus 1 to both sides of the equation, like that. And then therefore positive 1 and negative 1, these cancel out, leaving us with 2x is equal to 1. We want to find the value of x, so therefore we're going to divide by 2 on both sides. The reason we are dividing by 2 on both sides is because we have the coefficient of x is 2, and therefore we are dividing by 2. If the number was 3, we would have divided by 3, as we did in this on the left hand side. So therefore the 2's in the numerator and denominator cancels out, leaving us with x is equal to 1/2. So therefore the value of x here is 1/2, or the value of x is -4/3. So this, we have solved the quadratic equation by factoring. We have not only factored the given quadratic equation, but we have also used the zero factor property, and we were able to solve for the value of the variable x. So whenever we solve, one important note, observation we want to make here is whenever we solve a quadratic equation, we will have two solutions, x equals to -4/3 and x equals to 1/2. Those are the two solutions. So let me write that here. So the solution here is x is equal to -4/3 and x equals to 1/2. Both the given quadratic equation should satisfy both these equations. So I'm going to show how this process works. I'm going to show you the check process here. We will check it. We will take the given equation. Now let me write it a little bit more clear here. Check. Check. When x is equal to -4/3, how do we check it? We're going to write the given equation down, which is 6x² plus 5x minus 4 is equal to 0. Wherever we see x, we will substitute -4/3. 6 times -4/3 raised to the power of 2 plus 5 times -4/3 minus 4 is equal to 0. So here we can write this as 6 times negative is a positive. 4 times 4 is 16 divided by 3 times 3 is 9. So I've just expanded 4/3 raised to the power of 2 plus, because this we have a positive times negative is a negative, 5 times 4 is 20 divided by 3 minus 4 is equal to 0. In here I'm going to simplify this. 3 times 2 is 6, 3 times 3 is 9. So therefore I can write this as 2 times 16 is 32 divided by 3 minus 20 divided by 3 minus 4 divided by I'm going to write it like this. I want to multiply and divide. 4 means 4 divided by 1, and I'm going to multiply and divide this by 3. So I have a common denominator, therefore that is equal to 0. So in here, when we look at this expression here, the common denominator is 3. Common denominator is 3, and therefore I have 32 minus 30 minus 12 is equal to 0. So in here we needed to correct something here. This should be 32 minus 20 minus 12 divided by 3 is equal to 0. So 32 minus 20 is positive 12. Positive 12 minus 12 will be 0. 0 divided by 3 will be equal to 0. So therefore 0, therefore the 0 is equal to 0, therefore the left hand side is equal to the right hand side, and therefore the value of -4/3 what we have substituted into the given quadratic equation is exactly correct, and that is the way we want to check our answers. The second one, we can also use the second solution and then make sure that also satisfies the given expression. The second equation we have is this. I'm going to write here when x is equal to positive half, the given expression we have is 6x squared plus 5x minus 4 is equal to 0. When x equals to half, this is the way we want to substitute. 6 times 1 half raised to the power of 2 plus 5 times 1 half, like that, minus 4 is equal to 0. So I can simplify this as 6 times 1 divided by 4, 1 half, 1 squared is 1, 2 squared is 4, plus 5 over 2 minus 4 is equal to 0. So I can simplify this as 2 times 2 is 4, 2 times 3 is 6. So therefore what I have here is 3 over 2 plus 5 over 2 minus 4 over 1, and then I'm going to multiply and divide by 2, and that will make the denominator the same, then is equal to 0, is equal to 0. So I will simplify this some more. So the common denominator we have is 2, and then the terms we need to combine are 3 plus 5 minus, this is 5, not 6, this is 5, minus 8 divided by 2 is equal to 0. Okay, 3 plus 5 is 8, 8 minus 8 is 0, 0 divided by 2, that is equal to 0. Therefore the left hand side is equal to the right hand side, and therefore we come back here and then say the value of x equals to negative 1 half, which is one of the solutions, is also a true solution of the given quadratic equation. So this is the way we want to be able to use the procedure which we talked about to solve quadratic equations by factoring. We have not only used we have used the quadratic the procedure to factor out the quadratic equation and then use the zero factor property to be able to find the value of x. We went one step beyond, and we checked the solution by substituting one at a time into the given equation, and then making sure that the left hand side of the expression is exactly equal to the right hand side of the expression. So in my next presentation we shall look at some more examples related to solving quadratic equations by factoring.